Hello viewers, welcome back to video tutorial on AgentGrid. This is the second video in the observability. So for our previous videos, I request you to go to our OpenAGI.Network YouTube channel and check the service grid channel, sorry, the playlist. In that we have uploaded several videos about service grid, and the last video that we have discussed is about the metrics or the observability. In the previous video we have showed how to add the metrics for our one of our example. That was, we took a tools code. If you go to our GitHub, this is our GitHub Cosmos AI agent grid. If you go to the service grid examples, we have taken this folder and we have explained the codes inside it in the previous video, which is again a duplicate of the tools usage, but we have added the metrics to it. In the current video, we'll take the functions code and we'll add the metrics to it. So basically we have given you how to add the metrics for agent as well as the tool, and in this video we'll show you how to add the metrics for the, again, agents and the function. So currently there is a work that is pending, which is like we have to add the metrics properly to the functions, but I have added the code, but it is just that from the back end we need to scrape the metrics from the function pods. As you know that in the service grid we have type 1, type 2, type 3 functions. Type 1 is basically, we call it as tools because it will run inside the agent code itself, and in the type 2, type 3, they are basically functions which will run as an Kubernetes jobs or pods, sorry, Kubernetes deployments or jobs. So if it is a Kubernetes deployment, it is a type 3 and it is a stateful because it is a deployment, it will stay there until you remove it. Or if it is a type 2, which is about Kubernetes jobs, it is like fire and die. Once it is done, once its job is completed, it will get killed automatically. So right now we're in the process of adding a metrics server to it. So but scraping, we need to add it, but as such we can add a metrics code to it, but that's what I'll go to show you in this particular piece of in this video. And also we will be discussing about the logging, so how to check the logs or check the logs of this pods that is running, whether it's a function pod or whether it's an agent pod or whether it is any other pod in any namespace, how to check it with the help of Grafana Loki and Grafana Explore. So let's start the code. Let's start explaining the code of, as I mentioned, I have taken this metrics demo with functions. So here I have a nodes. In this nodes, I have two agents here. If you have seen our previous video, you know what these agents are. One is a code creator and one is a code reviewer. For code reviewer, it has three different functions. One is two are stateless and one is stateful. So stateless means it's a K8 job, and stateful, it is nothing but a K8 deployment. So in the K8's sorry, in the first agent code, we have added the metrics. That again, it is the same. If you have seen the previous video, it will remain same. We are not modified any things in it. We have just added, we have just introduced this self dot metrics, and whatever the call we wanted to make, whatever the observation we wanted to do, we have added those. So it will remain same, no changes. Same as for the second agent, we have added the same thing, but just that in our earlier video you would have seen tools, but in this video I have one special function. Instead of tools, I am calling a function. So I have a underscore call underscore functions, and in that function I am adding a span and the metrics that is required. So since it is a tool, as you remember, in our metrics util, we have added codes for tools. This is for LLM calls, this is for functional metrics, and this is for tool metrics. So whatever the metrics were there, we have updated in the previous video. We have updated this metrics, but in this video we'll be updating this function call metrics. So let me show you the function call metrics. uh, in on data only, we are calling the function call. So again, we have a nested tracers so that we can capture the timestamps properly. And I'm calling this call dot function, and for in the call dot function only, I'm adding the metrics related to the functions. As you can see here, I'm calling the actual function, and the function ID, input data, and parameters we are passing. And once it is once it is done, in the finally, I am adding the total function calls. So how many function the incrementing the function call did, and also the duration that was taken for the function call. If it is any exception, I'm just increasing the error total the counter in the exception. So this is related to the function call, whereas in our earlier video we had three different functions for tool call, and we were incrementing the metrics there in the each function. So here also we have a tracer to know how much time that was spent in this particular function call. So we have a function ID and we have a task ID, and we are giving a parent ID also. Parent ID is nothing but the this particular the tracer. We are passing the parent ID as user task ID. So sorry, the root span dot span ID, which is nothing but this particular span ID, basically the span ID that we got from this particular task dot task ID tracer. So this is the code of the agent. So let us check the code of the function. So in the functions, let me just go to this folder in the functions. So as you can see, we have a code folder in that function.py and requirement.txt. This is one function.py. So right now the code for stateless and stateful remains same. So I mean the structure of the code remains same. So you will not be able to see any difference between the stateful and stateless, but it is just that how they are deployed. So right now in this, I'm importing the metrics util. That was our util that we have created. So any new uh, uh, the counters or gauges or anything you want to add, you have to add it here. This is based on our primitives file we had in our core SDK. So I'm using metrics util agent metrics, though this file is not available at this point of time. But when you are building this bundled zip, we are just pushing it. I have made that changes to our build code. So I'll show you that in a moment. So we are importing that agent metrics and we are creating the metrics. We are passing some namespace, and we'll use this variable to update the metrics that is required in the function. So right now for functions, I have LLM calls is available, observe LLM calls. Basically this function was doing some LLM calls, so I have used those LLM calls updates only. So I have not used any other functions. But if you want to specifically break down each functions are calling, something like that, right? So you can always add. So right now it is just about LLM calls. So in the for that alone I have added the metrics. So there's a eval function. So the eval function is what will be called when a function runs, and parameters and input data will be passed to it, and the eval function creates a client required if you are passing a tool model, and then it will call this function, and in this function we are updating the metrics that is required. So same thing I have done for the second code, second function as well as third function. So there is no difference. So the difference that we would be seeing is in the build. So let me show you the build. So in the function we have a build.sh. So let me just show you that. So we have two functions here in this script where it is copy dependencies and clean dependencies. In the copy dependency, I'm adding the utils metrics utils.py to the code folder. The target folder here will be a code folder. So, and also I'm adding the agent SDK core metrics.py in the code folder, so that they they will be imported properly without any issues. So now whenever I'm zipping that module, I'll just zip I'll just do a copy deps function call and then the clean deps function call, so that once the zip is over, those files are also removed, so that we don't have to worry about in git tracking. So basically the code folder will have only those files, only the one file function.py and requirement.py .txt. Whenever it is building it, it will copy it, and after building it, it will remove those files. So this is the difference. Apart from that, there is no other difference you would see from the previous videos. So let me just run it. I'll come back to this logging in a moment, but before that I'll just run this my agent code. So let me just load it, deploy the agents, register the workflow, and deploy the workflow. So workflow is deploying. So let me check whether the agents are created or not. Yes, the agent is created. So let me run the input. Yes, so now it is going to the first agent, and once first agent is done, first agent is basically creates a code for a requirement. The requirement is basically asking for some functions. So it will create a code, it will give to the second agent. The second agent passes it to three different functions. In that three different function, one is a first is a stateless, then is a stateful, and then third is a stateless. So in the stateless, it will create the pod, it will run, it will do the evaluation, and once its results comes out, the pod will be evicted because it is a stateless. Then it will go to the stateful. The stateful, the pod is, if it is already deployed, because it's a Kubernetes deployment, it will not do a redeployment again, and it will do an eval. If it is not deployed, then the deployment function will happen. So all these backends are handled by the agent function library. So the agent function library I would have explained in the previous video. You can check our previous videos in the service grid playlist. So right now the inference has been done. So the work of the both agent has been done, and we got the output. So I'm not much concerned about the output right now, but I want to just to show you the dashboard. So let us go to the dashboard. So here you need to import the dashboard. In a earlier video, I have imported one file present, the Grafana dashboard.json for the tools. So we have a metrics demo. In that you have a Grafana dashboard, but currently since it is a function, so I have created the functions Grafana dashboard.json. So the difference between this and that is just one small difference. Let me just open and show it. So the title is changed, and also the UUID would have been a different one, and also the in the templating how would I kept the multiple agent prefix. So in the last video we had the tools, there was only one agent, so you would have seen in the options there was only one agent, but here you have a two agents. So that two agents I have kept from one after the other, and they are in a very sequence manner. So you can keep any there is no hard code rule that you need to keep the agents in this sequence only, because at the end they will come as an drop down in your dashboard, nothing else apart from that. So this is the Grafana dashboard. And also instead of in this title, instead of giving the the agent's name, I have given the workflow, because workflow name is the right one here to give, because it will engulf both the agents. So in our previous tools JSON, maybe there might be a name of the agent, it is just the title, so there is nothing in it. So you can always change the title to anything. So only this is the changes from the both the JSON, so there is no other difference in the both the JSON. So I have two agents here, so let me just upload that, we'll see how it works. So let me just, this is matrix demo with functions, so I'm just copy pasting it. So it will say this agent, this is already exists, but that's fine for me. If it says UUID also already exists, so you just change the UUID, and I'm just going to overwrite it. So as you can see, it has opened now, and let me just show you the graph. So I have done already one or two inferences, right? So I would have got some outputs here. So this is the pre-processing latency, P95, P90, and P50. It's all pre-processed. We have on data also. For that also have got some outputs, and similarly we have for function calls. Right now the tool calls may not be there because we have not activated any tools, but in this we have done a function call. So there are totally 3 function calls we have done. Right now this is for last 1 hour. So like if I change it to maybe last 30 minutes or 15 minutes or so, so we'll get then only for a current run. So let us keep it in last 1 hour. And uh, right now the as I told, the functions is not integrated properly with the scraping is not happening, so that's why we will not get the LM cost. Though you have added the metrics to the functions code, it has not been scraped. So but we'll update that in coming days. So now the spans. So basically this is the whole span, the time, the amount that it has spent for each and every function. So right now it is all, let me just select particular current run. So this was the task ID, task 23753. So let me just select that task 23753. Yes, so for the trace you can see, so this is the complete agent. So this, there are two agents here. One is this agent and this agent. So first agent took 6.36 seconds, whereas second agent took 25.4 seconds. And these are nothing but the the functions, the basically who that you see here. So if you see here, right, so the who, the this is basically, sorry, the other span. So those are the spans. Basically you have this many spans. One is a functions, each functions, and on data span, and also on preprocess. So right now for code validator, it took around 18.5 seconds. whereas other two functions, test generator 2.66 seconds and test runner, it took 14.17 seconds. So uh, together it will be part of a 31.7 second, because it is called an on data function. So if you add this 18 plus 4 plus 2, right, so it will come somewhere around 31.7 seconds. And the pre-process, it just took 1.60 milliseconds, and this data is belongs to this particular agent, so which is nothing but 25.4 second. And yeah, sorry, this on data is together both of these agents, that why it is showing as 31.7 seconds. Whereas when if you want individual agents, you need to write a separate queries for that. So right now it is for on data of both the agents. This is also on purpose of both the agents, but this is a that functions timestamp. So if you need any other further divided, right, so if you want to divide this agent and its on data of process, you can write a, you can give this dashboard to the ChatGPT or Gemini. You can ask for a modification such that it will list down its breakage as well, if in case you want it. So here is a cumulative where, as you can see, the first agent took around 6.36 seconds and the second agent took 25.4 second. So this is for a cumulative. So together, how much together it was somewhere around 32 point seconds. So basically it will list down how much each it has spent on each agent. So if you have more agents, then it looks a graph. It can stack multiple agents duration. So this is for one task, and if you want to check for all the tasks, you can select all the task, and then you will see here different graph size. So here this is for the one task, this for the second row is for second task, third row is for third task. So every time it has spent a different amount of time, though we were maybe inferencing the same task every time. It was basically time was changing. So it could be because of delays in the function call, or also maybe, yeah. So you can modify this graph.json. So we have given some examples, but you can always change the structure of this JSON files according to your requirement. So that's it. So this is the dashboard in the functions. So we have to do update from our side for scraping of the metrics from the function pod, because agent pod we have already scraped it, and for function pod, because this deploys a Kubernetes pod, so we have to add the scraper for those pods as well. So once we add that, you can get anything from the functions also, but I have added the code already for that. And now one other thing we want to show you is so you have to go to explore. We'll check the uh, logging now. So let's go to the explore, and here you need to select Loki. Prometheus is for Prometheus scraping, querying the PromQL with the help of PromQL. For Loki, it's about the logs of the pods. So as soon as you select Loki, here you will get different drop downs. So in that you can select anything you want. Like let me show you one thing. So namespace, and let me choose the agent's namespace, because I want to check the log of my pod. And this is on a agent namespace selection. So let me just again add one more, maybe the pod. And there are so many pods that you will see, right? So because past I would have run several agents here, so all the pods you will be able to see. But let me choose the pod that I want. So I'll take this particular pod. So let me just paste it. This is the pod. So this is for a you can use this tool for checking the live logs as well as the historic logs. So right now I'm taking one pod, and here, since this pod can contain multiple containers, I'm interested in the agent core. So agent core is the pod that we are interested in. That's what our code is running. So let me just run live. So this is the live logs, pod logs. So maybe 1521. Yeah, the latest one is in the bottom. So let us go. Since I don't want to know the live now, you can stop the live one, and you can do a query as well. So here line content. Let me say I want to check the error. So if you want to check error keyword, So you can basically do add the line contents. You have again several line does not contain, line content case sensitive, so etc. So many filters are there, so you can use line contents as you can see here. So let me just cancel this, stop the live one, and let me do the query, run the query. So there is no error in that. Maybe just let me see any other thing. Info, let me just run it. Yes, there are several info things that whatever the code you have done, right? So based on that you can search it. Let's say you had added some keys here, warning task missing, so you will not get that. In on data, any other logs are there. So basically you can take any of your keywords you want to search, and you can put it in the lines, line contents, then you will get those. And also you can search with the any pattern as well. So there is a way you can do a pattern. Let me just show you that pattern. Line contains label. So there is a pattern as well, so you can give any pattern. Let's say let me just take the pattern format. So this is one pattern format. So you can give basically I'm searching something with respect to the timestamp. So let me just run the query. So let me just remove the info maybe, so that you will see all the. Yes, so you can see all the timestamps that is listed. So you can basically search with the respect to pattern or line content or anything, any other operations you want to do, you can do it. So this will help in your postmortem analysis. Let's say something has run, something absurd things has happened from the agent in the morning, maybe yesterday night or something like that. So you want to go back to the timestamp, you can maybe check those with respect to the pattern and also the error or the any important log information. So instead of going and checking in the terminal, you can always use this particular Loki integration in the Grafana dashboard. So that's it for this video. So I hope you have learned about the observability stacks provided by the agent grid. So we have a metrics as well as we have a logs. For logs, you have to use a Grafana Loki and Grafana Explorer, whereas for a metrics, we have used Prometheus and the Grafana UI for displaying the real-time dashboard. So thanks for watching, and don't forget to subscribe the channel, and please, before watching this video, I request you to check again the previous videos. So thanks for watching.